All right, friends, welcome back. This is Module 2 on environmental indicators and sustainability. So an important part of environmental science is knowing how humans impact the natural world, both positively and negatively. And that's going to be a major theme for us throughout this year. And in order to understand this better, we first need to talk about ecosystem services. So ecosystem services are the processes by which life-supporting resources are produced. So I'll give you a second to think about what a couple of those might be. A process by which life-supporting resources are produced. All right, so a good option for this might be the water cycle, or the regrowth of trees, or something of that nature. So those things are really important because they will either directly or indirectly help people to survive. So those are important, and they play a key role in understanding environmental indicators. So what is an environmental indicator? An environmental indicator is an indicator that describes the state of an environmental system. There are 5 major ones that we'll be talking about. The first one is biodiversity. Second one is food production. The third one is average global surface temperature. The fourth is human population, and the fifth is resource depletion. And we'll talk about those a little bit more in detail. But ecosystem services are going to be designed to affect one of these 5 items that we'll be talking about. All right, so let's talk about the first one, biodiversity. So biodiversity is the diversity of life in the environment. So bio, life, diversity, differences. It's the diversity of life, the differences of life in a particular environment. That could be the global diversity, that could be in a particular biome, that could be in your town. It doesn't have to be any specific environment. But there are 3 types. The first one is genetic diversity. The second one is species diversity. And the third one is ecosystem diversity. And as you can see by this little triangle that I've drawn here, they kind of work. Ecosystem is the largest, species is a little bit smaller, and genetic is a little bit smaller than that. A really good image to look at for that is this one over here, figure 2.1. That one will really help kind of give you a feel for what we're talking about when we say each different type of diversity. So let's start with genetic diversity. Genetic diversity is the change in genetic variation among individuals, or the measure of genetic variation among individuals in a population. So we'll get into what individual, population, species, all of those things mean. But for now, what you need to know is that individuals are all of the same species. So from one person to another person, from one chipmunk to another chipmunk, there's going to be a slight variation in each of their genetic codes, in each of our genetic codes, that gives us a genetic diversity. The more genetic diversity that a particular species has, the greater disease resistance, and the greater species diversity overall. The second one, species diversity, that is, well, before we can talk about species diversity, we have to define species. So a species is an organism that is unique in its morphology, behavior, and biological processes. So what does that mean? So morphology is going to be the body form and structure. So for example, I have a different body form and structure than a bat. And a chipmunk has a different body form and structure than, say, a squirrel, even though they're similar. But it's also behavior and biological processes, right? So there are different biological processes in certain other species compared to me. So let's say a pig has different biological processes than I do. It also has a different behavior than I do, for the most part. So species diversity is the number of species in a region or ecosystem. And the greater the species diversity, the greater the ecosystem productivity, which is measured in, usually is measured in energy output. Species loss over time is natural, And we have what's called the background extinction rate, which we'll be talking about a little bit more in class. But the background extinction rate is the average rate at which a species becomes extinct over time. The current estimate is that the background extinction rate is something approximating one species per million years. And so with about 2 million species on the planet, we expect that the background extinction rate is approximately 2 species per year. Now that could be insects in the Amazon that we haven't even discovered yet. That could be certain unique plants. That could be the dodo bird. Who can say? And then we also have something that would be the opposite of the extinction rate, more or less, and that is called speciation. Speciation is the evolution of a new species, right? So it's the formation of a new species via evolution. We're just going to take that at face value for now. We'll get a chance to talk about that more in the future. But what I want you to know for now is what background extinction rate is and what speciation is. And I want to ask you the question, and we'll go over this in class a little bit, but just want to prepare you. We're going to ask, would we want those to be equal, ideally, and why or why not? And then we'll talk about whether or not it's feasible for those things to be equal, and what we can expect over time. All right, so let's talk about the last form of biodiversity, ecosystem diversity. Ecosystem diversity are different ecosystems in a given region. So for example, I can go from my house in Fry Springs, which is a lightly wooded suburban area, over to, say, Skyline Drive, which is a heavily wooded mountainous area. It has different soil. It has slightly different ecosystems going on. We could even say, my front yard compared to a pond. Those are different ecosystems. Great. Something that is kind of important for you to know when we're talking about different ecosystems and land and food production is a hectare. Hectare, the abbreviation is HA, and it's measured by 100 meters by 100 meters. There's about 2.5 acres in a hectare. Right, and I've written this out for you right here. I'm not going to have you do a lot of math on this. I just want you to know it. It'll make a lot more sense to you. A lot of other parts of the book will make a lot more sense to you if you remember this right here. All right, now we're moving on to indicator 2, which is food production. We measure food production health in 2 ways. The first one is consumption by humans per capita, and the second is production per capita. Just to talk about those for a quick sec. So per capita means per individual in a country, right? So in this instance, I'm wondering if you can actually read that or not. No. Let's see if I can get this a little closer. That's probably a little better. Okay, so talking about production per capita, so per individual in a country or in a particular region. So what is the consumption by humans per human? So if we averaged out the amount of food that's eaten across the world divided by the number of humans, that would be consumption per capita. The second is production per capita. So not everyone is a farmer, not everyone is a butcher, etc. And so not everybody is going to be producing food. So we do it in the same way. We take overall food production and divide it by the total number of people in a particular region. And I want to ask you, do you think we would want each of those individual ones to be level, or would we want them to be growing, or would we want them to be decreasing, and why? And we'll discuss that in class a little bit tomorrow. All right. So next part. Now I want to talk about global surface temperature and carbon dioxide concentrations. So if we go back to our very first page, remember, average global surface temperature is one of our environmental indicators. And That is because temperature of the surface affects our weather and also affects our ability to sustain particular environments. So for example, if suddenly, our summers were 40 degrees Fahrenheit, that would be way too cold for anything to grow, and we would lose all of our food production. Likewise, if our summers are suddenly 120 degrees Fahrenheit, they would be way too hot, and we would not be able to grow food. All right, so a stable climate enables increased food production and increased biodiversity. This is enabled by greenhouse gases. And I'm sure a lot of you have heard of greenhouse gases before, but I'm going to just comment on them again. So a greenhouse gas is a gas in Earth's atmosphere that acts as a very good insulator, which means that it traps heat. And these insulators will trap heat near the surface. We'll talk about this a little bit more when we talk in our atmospheric science unit. But for now, greenhouse gases are gases in Earth's atmosphere that trap heat near the surface. Now, if we have too much of those, then we have too hot of a climate, which prevents heat from escaping, which causes the average global surface temperature to increase over time, which can potentially destabilize our food production, our biodiversity, or even our climate. This is a really great figure right here. I want you to take a quick look at it. And I want you to ask the question, do you think that warming is anthropogenic? And anthropogenic means derived from humans. So just looking at what we have right here, I want you to ask that question. And I want you to come up with a couple of good reasons why it might be. And I want you to see if you can come up with a couple of reasons why it might not be. And we'll discuss that more in class tomorrow. Or whenever this is due. Human population growth can stress, I'm going to go back. Number four is human population. So in addition to biodiversity, food production, and global surface temperature, the size of the human population can tell us about the health of our global environment. Basically, human population growth can stress our systems of food production and chemical cycling, such as the carbon cycle or the water cycle, and can prevent us from maintaining our current supply of natural services or ecological services. Going back to the front, right? Our ecosystem services, right? Those can be degraded over time by an increase in human consumption because of increased human population. Great. All right, so number 5, resource depletion. So Earth provides those natural resources that we talked about earlier, and they're both renewable and non-renewable. Your book says that things such as coal and oil are non-renewable, but they define that as they are finite and cannot be renewed or reused. That is not technically true for coal and oil. It just takes a very, very, very long time for them to be replaced. And so they are effectively, it takes longer than a lifetime. So they are effectively not renewable, but that is not totally true. And I just want to make that quick distinction. But there are certain things like uranium that are finite, and we do only have a set amount of them, and it cannot be reused, at least not with our current understanding of the world. We often measure resource use, like I said earlier, in per capita, which is the amount per person in a country or other unit of population. And so the real key here is that we can measure how many resources we're consuming and divide it by the total number of people and compare that to the amount that is produced to see how quickly we're depleting our resources. All right, so how do we assess sustainability? Well, in order to assess it, first we have to describe what it is. So sustainability is living on Earth in such a way that humans can use the resources without depriving future generations of those resources. So for example, if we cut down trees faster than they can grow, then we are not living sustainably, right? And so we want to be sustainable because that gives the future of humanity an opportunity to be successful. All right, so what is required for sustainable living? Well, first, systems must be able to recover. So we can't destroy a system before it's able to recover, right? We also want to say that renewable resource use must be equal to resource generation. So if we're using renewable resources faster than they can be replaced, then that's not good. And then we want to use our non-renewable resources sparingly. One of the key ways to do this, as prescribed by the book, is called sustainable development, which is development that balances human well-being and economic development with resource management. Let's see if I can. With resource management. Great. If you can't read that, it's this right here. So this is the exact same thing. Great. So remember that. Our goal is to develop our country further by balancing human well-being and economic development with resource management. That means that we don't want to sacrifice human well-being for our resources, and we also don't want to sacrifice our resources for human well-being. That is according to the book. In my opinion, I think that human well-being should take precedent over resource management, but I think that we should work really hard to not have to choose between the two. I'd be interested to hear your thoughts on that in the future. All right, zooming back out again. In order to kind of define how to live sustainably as prescribed by the book, we have to kind of define human needs a little bit. So your book talks about two types of needs, basic needs and complex needs. Basic needs of human life are simple, like air, water, food, and shelter. Right? Notice how that does not include things like air conditioning, antibiotics, things like electricity or plumbing, right? Those are not listed. And then the book also lists complex needs, such as community or interactions with people or with other living things. And I want to ask, should we stop our sustainability goals there? Or do you think we should go further? Are there more things that we should introduce into the human population, or into human life rather, that that would make it better to be a human on Earth? Or should we stop at basic human needs and kind of go from there? What are your thoughts? All right, last thing. Want to talk about the ecological footprint. So the ecological footprint is, as we said earlier, a measure of how much an individual consumes, and it's often expressed in an area of land. So it's a measurement by which we discover how many resources we use, and we talk about it usually in a measurement of land. So for example, how many planets do you need to, if everybody were to live the way that you currently live? We're going to be doing an activity tomorrow, or whenever this is due, next class, on this specifically, so that we can grade how well we are doing individually in terms of how many resources we're using. Great, that's it. Sorry this was a little bit longer, but there's a lot of good information in here. Remember, there will be a quiz on campus. Please take that, and I will see you next class.